Tornadoes are the smallest of the low-pressure systems, but they can be the most destructive. They're formed in association with supercell thunderstorms, where mesocyclones have formed. Mesocyclone is like a mini whirlwind inside the cloud. They can form in any situation where you have cold, dry air that is clashing with warm, moist air. Remember, the moisture, that is the fuel. That's the jet fuel for these weather systems to take off. The wind speed, or actually the severity of the damage, which is related to wind speed, is measured on the Enhanced Fujita scale. Dr. Ted Fujita was a tornado researcher at the University of Chicago, and he went wherever tornadoes had been detected, measuring what the damages were. So he got the honor of having the wind speed scale named after him. The scale goes from EF0 to EF5, with EF5 being the most destructive. Tornadoes can form over water, and if they form over water, they are called waterspouts. Until the development of Doppler radar in the 1940s for use in weather, tornadoes were these monsters from the sky that appeared without any warning to wreak death and destruction on an unsuspecting population. In fact, they instilled such fear in the population and were so unpredictable that in the early part of the 20th century, there could be no mention of a tornado in a weather forecast for fear of inducing mass hysteria in the population. They were certainly known by Native American tribes that lived on the Great Plains, which is part of Tornado Alley, although it wasn't called that then. The Cheyenne and the Arapaho thought that whirlwinds were created by caterpillars. Well, entomologists now know that they hatch when the barometric pressure drops right before a storm. In Romania, where tornadoes are not that common, but when they did occur, they were terrifying. Romanian lore talked about dragons that would appear in the sky with long lashing tails, deafening roars, and breath that turned water to ice. Now, I don't know how a dragon's able to do that, and they would carry people in the sky, and when they left, there was just mass destruction in their wake. This is the Storm Prediction Center in Norman, Oklahoma, which is located in the heart of Tornado Alley. This is part of the National Weather Service, part of NOAA, National Oceanic and Atmospheric Administration, and it's on the campus of the University of Oklahoma. This map shows the average annual number of tornadoes by state, and we see that Texas takes the cake here, 146.7. Texas is a large state though, so there's a lot of room here for tornadoes to occur. Then number 2 would be Kansas, and then at number 3 is Oklahoma. Oklahoma is where the Storm Prediction Center is located. So they're right there in Tornado Alley. Another Tornado Alley is being defined now, and it's over in this part of the country where these tornadoes are seen and increasing in number. Florida, look at Florida, 54.6. So it's in the red too, just like Nebraska, Oklahoma, Nebraska, Kansas, and Oklahoma are. West Virginia is in the white, 2.4. New England up here in the white, as you would kind of expect. California, 10.6. Nevada, 1.9. Well, you got to have moisture, so that makes sense. Not a lot of tornadoes going to happen there because not a lot of water vapor. The states in yellow here have traditionally been the old Tornado Alley, but we're finding increasingly tornadoes impacting these states in large numbers. So this is the new Tornado Alley. This gives you an idea of why this region of the country is now becoming a tornado alley too, or Dixie Alley through here as they call it. This tornado outbreak happened April 12th through 13th, 2020. This is when we were all under social distancing because of the COVID outbreak, so that added a whole nother layer that had to be considered with all this going on. But the tornadoes were over 10 states from Texas into Virginia. Charleston, South Carolina had to declare its first ever tornado emergency. There were 140 tornadoes in all. One of them was confirmed to be an EF4 that had wind speeds of 190 miles per hour. And then there was one in Mississippi that reached a width of 2.25 miles. Now that would be some horrible beast headed towards you. 32 fatalities, and that was the deadliest outbreak since April the 27th through the 30th in 2014. There were multiple vortices that were spawned throughout the 2 days that people were terrorized by this. And this is some of the damages that occurred. This is a grove of trees that's been destroyed, and you can see how these trees, the bark has been removed from the trees. That was an EF3 tornado that hit in South Carolina. This is a mobile home and trees that were destroyed by an EF4 tornado. I think this was in Mississippi. You would never even know what that pile of debris was there. This is another supercell outbreak of tornadoes, but this was in April of 2011. This is Alabama, portion of Alabama, and you can see all of the tornadoes that were spawned here, one of them being an EF5, this one up here with the pinky colored line. And this is the full extent of that outbreak. Here we are in Louisiana right here, then across Mississippi, Alabama, Georgia, North Carolina, Tennessee, into Virginia. 758 tornadoes were recorded in April of 2011. That beat the previous record in 1974 of 267 tornadoes. This one is notable to me because I am from this part of Virginia right here, the southwestern part of Virginia, not West Virginia, the southwestern part of Virginia. And my sister was living there. We grew up there. She stayed there, and then moved to Florida, and after her first hurricane, moved back to Virginia. Anyhow, I digress. She was living there, and I was very worried because I knew I'd been following the weather reports, and I knew that they could be, some tornadoes could be spawned in our area. And it didn't hit right where she lived, but it hit across the mountain. And she said that the storm was unlike anything she had ever encountered. The lightning was horrendous. The wind was horrendous, but luckily the tornado didn't hit right where she was. And then these are tornado tracks. So you can see the areas of the country where they impact. The brighter the color, the greater the frequency of tornadoes in that area. And you see that, yeah, we get some here in California, but we're certainly not lit up like a Christmas tree here like these are. West Virginia, very few tornadoes. How do tornadoes develop? There's still an awful lot we don't know about how tornadoes develop. Doppler radar can tell us whether we have a mesocyclone inside the cloud, but it can't tell us anything about what is going on inside the funnel cloud itself. So the first thing that happens is on any given day, we have wind, air, that is moving, rolling along horizontally in the sky. If you don't believe me, look at a contrail every now and again. Sometimes you'll see it twisting on itself. So it's thought that whenever a thunderstorm develops, and remember a thunderstorm has these very strong updrafts associated with it, that the updraft picks up that horizontal rolling air and tilts it vertically, and that's the development of the mesocyclone. Then we get a tornado watch if conditions seem favorable to the development of a tornado, and we get a tornado warning if a funnel cloud has been spotted. And here's a big supercell thunderstorm, and you can see a tornado that has developed underneath it. You might be wondering why Tornado Alley is such a good breeding ground for tornadoes. Well, you have to think back to air masses. From northern Canada, we have cold, dry air coming down. And from the Gulf of Mexico, we have warm, moist air moving into this part of the country from the south. So cold, dry air from the north, warm, moist air from the south. And the thing to keep in mind is as the temperatures on the globe continue to warm, we get more water evaporated. So there's this air that's coming up from the Gulf of Mexico is going to have even more water vapor in it. And the dry line is what meteorologists that are into forecasting these events talk about. Instead of warm fronts and cold fronts, the dry line is just the boundary between the cold, dry air and the warm, moist air. So we have the ingredients necessary for instability. We have water vapor, and we have warming of the air. So when the ground surface warms up, what happens? Air is uplifted and it cools down, reaches the dew point temperature, and that's how we get clouds, right? So if that air inside those clouds remains warmer than the air outside the clouds, then those clouds will just continue to grow up on their own. And we have that necessary combination going on here. So high dew point temperatures at the surface. Well, high dew point temperatures, remember what your sling psychrometer does. You have the air temperature, and then you have the wet bulb thermometer that you put the water on, you sling it around, and that temperature will decrease if there's not much difference between the wet bulb and the dry bulb. That means that the air is moist. If there's a big difference between the wet bulb and the dry bulb, that means that the air is not so moist. So that moist air with those high dew point temperatures are necessary. Then some of the other things that we need are wind shear. Wind shear is where the wind will increase with height, but we also need it to change direction. We call that shear, wind shear. So that change of direction will give us that spin that we need in clouds for that tornadic activity to take place. That forcing mechanism we already have. The forcing mechanism would be the uplift of the air, but then we got something else going on here. The air would be uplifting on its own because of the warm temperatures, but now we've got this dry line coming through, and just that's a front, right? So we have a frontal boundary, so that provides the uplift necessary too. So if we have all of those in just the right combination, then a tornado could form. One of the other ingredients that's necessary is wind shear. Wind shear is where we have the wind increasing with speed, with height, and also we need the wind to change direction with height. That will give a spin. That will give a spin on the clouds. And for tornadic activity to take place, the clouds have to spin. So this is one of those supercell thunderstorms. And just look at how tightly that's spinning. Notice the counterclockwise motion. Here's a supercell thunderstorm. This is punching through. Once we get the anvil head, remember the temperature inside the cloud is equalizing with the temperature outside the cloud, but if there's still some forcing mechanism in here, the cloud can punch up to a higher elevation. Here's a supercell that has spawned a tornado. That looks like it could be another one right there. And here's a full-fledged tornado. That funnel cloud, that's just condensation, condensed water swirling around. Here's another one. They could take on all kinds of different shapes. Not all of them are funnel shaped. Sometimes you can have these vortices that grow together. Sometimes you can have just a wedge shape. These are the baddies when you have a wedge shape tornado on the ground. Look at this one. It has that perfect tornado shape. Look at that tight circulation. Perfect definition between the funnel cloud itself and the air. That's why these things seem so otherworldly. This looks like it's moving over plowed ground, so it's probably picking up some of that, giving it that darker color. This is one of the few tornadoes that was spinning clockwise. This was in Colorado several years ago. It looks like a corkscrew, doesn't it? Then this is a waterspout. This is a tornado that has occurred over water. These can pick things up like fish, and if it moves onto land, it'll drop the fish or the frogs or whatever it is on land. This is one of those wedge tornadoes. Look at that. Very, very nasty. This one in particular was in El Reno, Oklahoma. This tornado that spun up on May 31st, 2013 in El Reno, Oklahoma, which is a small town located just to the west of Oklahoma City, it was of epic historical proportions for several reasons. First of all, it was the widest ever recorded at 2.6 miles. Can you imagine that? Wind speed, highest wind speed was clocked at 300 miles per hour. And it moved on an erratic path. Most tornadoes move to the northeast. This one started moving that direction and then changed direction several times. It was a wedge tornado, and it had multiple vortices associated with it, which are multiple tornadoes that were hidden by rain, which made it even more difficult. It killed 3 professional storm chasers, and that was the first time in storm chasing history that any of them had been killed. One of them was Tim Samaras, his son, and his driver, who was a meteorologist. They were part of this team called Twistex. And Tim had been storm chasing for years. His whole thing was finding out what was going on, trying to find out what was going on in the interior of the tornado in order to give people more lead time. As it is right now, there's about 13 minutes lead time on spotting a tornado till it hits the ground and moves over a population. So he had developed these instruments. He was well respected. He had worked for National Geographic. He was on the Discovery Channel Storm Chasers, although he had a hard time with that because he thought it was too artificial. And also they just were looking for the big thing. He was looking for the big thing too, but he was looking for the big thing so that he could figure out what was going on inside it. And he had developed these instruments that he could release inside the tornado, but he had an instant to do it. So that was his whole thing. He had a tornado, I think it's somewhere in South Dakota, he had measured with his instruments the lowest pressure ever in a tornado. But that was bad news. So 3 were killed, 1 amateur was killed, and there were several people from the Weather Channel that ended up with severe injuries. The driver of Mike Bettis, who is an on-air personality, had a broken neck and some broken vertebrae and had to be operated on. This is the vehicle that Tim was in with his son. He was found still belted into the wreck, but the bodies of his son and the driver were flung about a quarter of a mile away from the car in opposite directions. The car was upright, it had the wheels blown off, and the engine was found a quarter of a mile away. This was an EF5, of course, and there had been an EF5 that had hit just 11 days before in Moore, Oklahoma, which is about 25 miles away from El Reno. That was the first time that there had been EF5s to occur so close together in time. And there's another view of the car. Maybe one of the lessons of this is that you shouldn't drive a Chevy Cobalt into a tornado. Here he is. There, that's the spread that National Geographic did after his death. The monster storm, the greatest storm chaser, Tim Samaras, devoted his life to unlocking the mysteries of extreme weather. Then came the tornado of May 31st. And this is one of the iconic images of him, I think when he was working for National Geographic or when they were funding some of his research. This is some of the damage from that tornado. I mean, it's hard to know what any of this was. Here's more. There are actually 20 people in all that were killed by this tornado. And this is the supercell thunderstorm that spawned the tornado. So why? Why do some supercell thunderstorms spawn tornadoes? Why do some not? Why are some large? Why are they small? These are some of the questions that still need to be answered about tornadoes. This is Moore, Oklahoma, the other EF5. This is a school where 7 children were killed. This is a neighborhood. And in this series of pictures, I wanted to show you, I'll quickly go through these just to show you what kind of damages are expected from EF0 to EF5. This is an EF0. That, believe it or not, is considered to be light damage. This is an EF1. House was not on a foundation, so that's considered moderate damage, 86 to 110 miles per hour. This is marginal EF2, 111 to 135 miles per hour damage, considerable damage. EF3, 136 to 165 miles per hour. Any removal of inner walls will constitute an F3 damage, so that was a high-end F3. EF4, 166 to 200 miles per hour. That's considered to be a devastating tornado. And then this is damage from an EF5, greater than 200 miles per hour, incredible damage. So foundations are just wiped clean. After all that talk of death and destruction, maybe we need a little comic relief, and The Onion can provide that to us. These are their rules for tornado safety. My favorite one is, where did it go? Oh, prevent tornadoes before they happen. Make sure that warm, moist air fronts do not converge with cool, dry ones. In the event of a tornado, lie down in a ditch. That happens to be true. If the only place you can go, if you're on the road, the only place you can go is in a ditch, you should do it. Don't stay in your car. One of the other things that people used to say is if you're in your house, open your windows, because the pressure differential will keep the tornado from doing any damage. That's total bunk. If you're in a house, you should go in the basement or go into an interior central room where you have more protection. Some people end up in bathtubs, and bathtubs end up being kind of safe. A lot of people have survived from being in a bathtub. All right, that's tornadoes. Hurricanes will be next.